Alright, so I think I figured out a way to get Blender to do BlenderCAM to do roughing passes and finishing passes, like a two-pass system. Yeah, you can do a lot of high detail stuff with like lower times doing it that way, because you can clear out the bulk of the milling with a big mill, and then you can just come back and do the middle section that needs detail with the high detail. I'm actually trying to set up the high detail part first, because that's the harder part. I think I figured it out. When you first open up BlenderCAM, it'll look like this. You kind of hit this little arrow. It brings up these options, these little tools that's hiding over here. And BlenderCAM has its own set of tools. If you click on the object you're working with, like I'll click on CAD here, and you click Object Silhouette, it's going to create this silhouette object, which is basically just a curve object that's a silhouette of the 3D object. That by default is a little small to use, because it's like right up against it, so it's not going to mill like down to the surface at all around it. They have this silhouette offset option for that, so you click that, and then by default it's set to this 3mm. Come down here, and I'm going to change that to just 1.5, so that should be enough. Alright, so now that we have that silhouette set up, we have to tell Blender to only mill in that area, and to do that we're going to use this use limit curve. So we'll just click that. I don't know why it has all these cat things in here. Find the offset curve that we made, and just to explain, I'm using this 1mm ball nose bit, and it's a 200mm per second fill rate. It's using that meander zigzag style, so it's just going to mill back and forth, saving some time. And it's at 0.3mm between tool paths, so it is a pretty fine detail cut. So we'll go ahead and calculate that. Alright, so that mills all the way around it. Pretty good, but it doesn't mill, you know, outside here at all. That'll be for the roughing pass. That should get everything there. It says it's going to take 2 hours and 13 minutes. Last time it was kind of accurate on that. It took about a half an hour longer. So that is a while, but the result will hopefully be worth it, since this should be really defined. Yeah, I should mention, I have it in millimeter scale. I was messing around with that meter scale for a while. You know, by default it was on meters. I changed it to millimeters, which makes it a lot easier if you're working with millimeters, because then, you know, here all I have to do is type 3 and it knows what I'm talking about. Before I had to type 3 mm, and then it would switch it to meters because it was in the scale of meters. And if I forgot to type the mm, it would put it in meters and it would throw everything off. So I like to switch that over. Alright, for the roughing pass, it's going to be 2mm between passes, which might make a rough edge, but I don't really care about the edge. Not really sure what that does. Might have something to do with the vertical. Skin I'm going to put on 1mm, because I want it to be smaller than the silhouette offset of 1.5mm, just to make sure that there's an overlap and everything gets cut away there. I'm definitely going to take that off. Alright, cool. Well, that allows us to see the roughing pass and the finishing pass in one thing there. If you consider that that's the distance between the tool pass and it's 2 millimeters, that distance between that and there should be fine. Yeah, I think it should be fine. If not, then guess I'll have to try more offset to carve away more with the fine bit, or less skin to carve away more with the roughing bit. I wanted to leave as much room as possible, but, you know, there's really tons of room. Probably didn't even need to add the skin. I'll see how that works though. Alright, so the 3 millimeters at the 3 millimeter bit at the 200 millimeter per second was just killing that 3018. I'm not sure. It looked in the video like something was pulling the wire. I think it was like just the resistance. That's kind of the small wire. I think it was just contorting the wire because of what was going on with that motor. I don't know. Definitely didn't sound good as soon as it hit. It was like, I didn't sound like it was too healthy. That machine's not big enough to make sounds like that. Let's see here. Probably want to do a step down instead of it going all the way down at once. Do a 3 millimeter step down. Do I want to slow down the feed rate? We'll slow the feed rate down to 150. And I actually want to change this to 1.5 because I feel like it might not clear. I wasn't worried about it clearing the edge border, but I worry about it not getting close enough to some of these areas in here with a big distance between tool paths. So hopefully that won't break the machine. Looks like it's doing it in 4 passes now. No, there's this tiny little extra pass. I'm gonna make it a tiny bit more so it can skip that last extra pass. I'm not even sure. I think the height is like 12 point something, so it makes sense that it's doing 5 passes. It could just do 4. If it was 3.05 probably. I'm gonna say 3.0. No, not O. .2 millimeters in a pass should eliminate that bottom extra pass. Alright, so it'll be 4 passes. This is going to take 2 hours and 29 minutes. I do have it at that slow, only 150 millimeters per minute feed rate. I figured after that abuse I just put the machine through. I want to make sure it's going to actually be able to handle this. I never used any bigger than a 1 millimeter end mill before. And at that it was at like a 2.5 millimeter pass at a time, so we'll see how it does with this. I was using the paper to check the Z height of the bit before zeroing out the Z axis, because I had to try to get the ball nose bit for the pass 2 to be like the exact same height. I used a piece of scrap 16th inch aluminum with a couple of holes in it to clamp on the right side to deal with the clearance issues I had before. I'm probably going to use that a lot. That seems to work really good. Even at the 3.2 millimeters per pass though, this machine and the bit seem to struggle. I think these end mills are kind of like, they're not really fluted, they're just like spikes. I don't think they're really the most efficient end mills. In that previous video I used that 2 millimeter ball nose, and that dug into the whole 12.6 millimeters of the relief like I tried to do earlier in this video with the 3 millimeter end mill. It didn't end well. So it seems like the flutes really help move material out, helps the machine a lot. Changing the tool, I'm going to move it up on the Z. You gotta be really careful you don't bottom out anywhere, but if you bottom down the Z, it doesn't matter as much because you're gonna be redoing that Z axis. You're gonna be zeroing it out. Oops. Alright, so the idea is not to move the spindle, not to move the carriage rather, like at all. Just trying to stabilize it with that wrench as I mess with it. There we go. It's the 3-inch end mill we were using. There's the 1 millimeter ball nose. Oops. Make sure that's good and tight. I hope I didn't just move that at all. And now I have to bring this down a little bit. Now let's get to a spot. Just to make sure, I definitely don't want to bottom out on the left to right. Alright, so now I can change this to 1, not 10. Alright. Must have embedded it in the wood a little bit there. Alright, there it is. So, very important, reset the Z and the Z only. Alright, so the work coordinates are still saved, but the Z has been reset. So now we're going to open this mouse situation I have going on right now is not ideal. Let's see here. For some reason the mouse only works on my pants. G code pass 2. Cat pass 2, 1mm ball nose. That's the one. Alright. Here goes nothing. Yeah, that looks like 0 to me. Alright, cool. It should do it. Not out of the woods yet, though. So this wood is like a soft pine. The bit looks really tiny. The ball nose is 1mm, but like along the flutes, it's like half that. It looks like, I imagine the feed rate would have to be slower for harder woods. It did seem to even like was making some noises, which I didn't think that bit could handle, but I think the spindle was kind of resistant, even at that speed. It didn't break or nothing. Shout out to Blender and BlenderCAM, of course. This is like super powerful software and it's free. You know, if I ever made money off this, I would definitely donate money to Blender and BlenderCAM, and I would recommend you do the same. I think the end result came out pretty good. I'm mostly happy that the roughing and finishing passes are possible with BlenderCAM, and that silhouette limit curve system, that's going to be super useful. Like, that would have been really useful in that other project with the little leaf mill out.